Hello, this is Wooddynne Dejeanlouis and Daniella Ineza presenting to you Ferro-Cement water tank for EWB Humanitarian Library. Water tanks are usually used to provide storage for water, used in many applications such as drinking water, irrigation, fire suppression, plants and livestock, food preparation, etc.
A little more information on what ferrocement is. Ferrocement, also called ferroconcrete, is a rich cement mortar that has layered wired mesh. Additional wire is also added on to add more strength.
Now let's dive into the subject by describing the structure of the water tank. First, you have to know that it has thin steel rods used to construct the frame and then covered with a metal mesh for the circular form. Thin layers of sand and cement are plastered over at the end.
There are different methods of construction of a ferrocement water tank, and the different methods mostly have to do with the formwork. A formwork is a temporary or permanent mold into which concrete is poured. You can build a ferrocement water tank without the formwork, which would require a stiff wire frame. You can build with a temporary formwork that is removed once the structure is complete, or a permanent formwork. Lastly, you can build a centrally produced ferrocement water tank, which is just a smaller water tank that can be transported. Or you can have a larger water tank built in parts so that it can be removed and transported individually. Here are the simple stages of building a ferrocement water tank. First, you want to lay the foundation. A site is cleared for any debris and the topsoil is removed to a depth of 100 millimeters. After you lay the foundation, you want to lay the base, which is 50 millimeters of concrete, then a wire reinforcement, and then another 50 millimeters of concrete to return back to ground level. Then a wall wire frame is constructed around the site. For larger ferrocement tanks, wooden shuttering is added for additional support. After, mesh or chicken wire is added inside and outside the wall frame.
We are now going to talk about how the fittings are installed in the whole structure. You have to make sure that you install them before you put the plaster around the walls. And the way you are doing that is that you attach whatever fittings that you're doing. So as you see on the picture below, we were showing a tab that they had attached to the walls, and then you secure it by using a plate welded to the pipe and embedded in the ferro-cement. An additional cement mortar will be plastered around the tap to prevent leakage. After you are done installing all the fittings, that's when you are doing the plastering by starting with the outside wall. And then you have to make sure that you are leaving some space for the ladder for you to have access to the inside of the structure. You have to make sure that you still have some steel rods that are coming out of the whole structure because you need them for the roof that you will construct after. And then in order to avoid ground erosion, you have to can pour a concrete platform around the structure. For such as for any other water storage construction that you are doing, we want to be able to prevent evaporation, pollution, or the breeding of mosquitoes, and especially in the given the areas that we are thinking about constructing this water tank for, so Kibo in this case, it's very important that you have a roof to cover the whole structure to prevent those. So we have different forms that you can use, but the arced one is the one that is increasingly being used around, especially because it's cheaper than the rest of the other forms because it's not it's cheap because it's not made of reinforced concrete. Now let's look at the different advantages that the ferro-cement water tank has, especially over the other materials. First is that the cost of reinforcing bars needed for large concrete and brickwork tanks will be saved, so it is cost effective. It has a lower maintenance cost than steel, and because for ferrous cement tanks there is no need to purchase and transport large quantities of masonry, stones, aggregates, or bricks, it has an easy transportation cost and overall transportation than other materials. For ferrous cement tanks, even though construction level it is level intensive, it requires relatively low level skills and fewer tools than other materials, which is again very effective and practical given the communities we are thinking about constructing the tanks in. Therefore, as I was saying, it's very ideal for use in many developing countries. The other advantage is that the tanks can be rapidly constructed and the raw materials are widely available. Also, and lastly, it produces much lighter structures than those constructed from brick, stone, and concrete.
Some disadvantages of the ferrocement water tank is that it can be punctured easily when it comes into contact with sharp objects. There also could be corrosion of some material if they are not completely covered by the motor. It is also difficult to fasten the fittings of the cement water tank with bolts, nails, and screws. And the sand used for ferrocement water tanks can be more expensive because you need a good, clean, and well-graded sand in order to build a quality water tank. Other disadvantages are the larger amount of labor is needed to build the water tank and the cost of these laborers. Also, tying the rods and mesh together is tedious and time consuming. And there are additional expenses when it comes to the fittings that you want to install. So what does ferrocement water tanks have to do in the context of Engineers Without Borders, and how has Engineers Without Borders utilized ferrocement water tanks?
So Andrew Bowie, who was a volunteer and engineer with Engineers Without Borders, created a ferrocement water tank for San Lorenzo, Guatemala.
Given the type of problems of water access that the community had, a ferrocement water tank was a solution, and a cement-like structure that was constructed would hold up to 65,000 gallons of clean water. After that, in Cameroon in 2010, EWB traveled to Bamendju to construct a 20,000 liters ferrocement storage tank at the highest location in the community, located next to a school. The purpose of this tank was to serve as a reservoir and, with the help of gravity, distribute this water throughout the community.
So what does that mean for us? When we are looking for solutions for the lack of access to clean water in developing countries, such as in Kibon, Kenya, it is important for us to determine the disadvantages and advantages of different water storage systems to determine what will be more useful.
Here is a slide of the different references, and I would also like to thank EWB Harvard chapter for their help and assistance in developing this project presentation too.
So what does this mean for us? So when we're looking to build different structures that would provide water for communities that need it, it is important for us to look in depth um, about these different structures and to understand the advantages and disadvantages of each, especially in terms of cost and durability, so that these communities could have access to clean water.
You would like to do